Welcome to this chemistry unit on 8.3, metals. In this lesson, we are going to learn about the history of metals, how metals have been used over the ages for everyday use, and why we have had different ages through the metals, such as the Copper Age, Bronze Age, and the Iron Age. So the history of metals. Metals have been extracted and used for many thousands of years. The science of metallurgy began in the Middle East about 10,000 years ago. Before this time, people lived in simple agricultural communities. And this is what we refer to as the Stone Age. So people used stone, bone, and wood to make weapons and tools. The first urban civilizations were about to begin. Exactly when metals were discovered is lost in the mists of time. We do know, however, that the Sumer people, around 3000 to 2000 BC, of the ancient lands which today we call Iraq, obtained metals from the surrounding mountains. Archaeologists are not certain whether gold or copper was the first metal used by ancient people. Some believe that gold is a more likely candidate because it can be found as nuggets in eroded hillsides and in streams. Its bright yellow colour would have attracted people to find and use it. Others believe that copper is more likely the first metal to be used because of its abundance in the regions where the earliest goldsmiths lived. Gold was of great significance to the ancient Egyptians. Nubia, the land of gold, was a valuable source of Egyptian gold. About 100 mines operated in this area, and slaves were forced to dig deep shafts to extract the metal from quartz veins. At the surface, the gold-bearing quartz was crushed using primitive stone mills. Water was then used to wash and remove the quartz powder from the heavier gold dust and granules. Finally, the gold was melted and purified in large clay vessels. The gold was shaped into rings and taken back to Egypt. Now, at this point in time, gold was mainly used as a decorative metal. This was due to its softness and malleability. So what people really needed was to find a metal that was much stronger than gold. And this is how the Copper Age came about. So copper was found to be much harder, and there were a lot more practical uses discovered for using copper. The time in the Middle East, around 6000 BC, is known as the Copper Age. All over this region, the rocky plains and hills contained veins of native copper and copper ores. The pieces of pure copper were fashioned into jewellery, fish hooks and pins as long ago as 9500 BC. But the brightly coloured ores had no other use than in decoration. Archaeological evidence shows that between 6500 BC and 5200 BC, the use of copper became quite common. This suggests that people traded quite extensively in the metal along the recognised trade routes. It was not till 4000 BC that the method of conversion of copper minerals into copper was discovered. This process was called smelting. So let's now have a look at the process of smelting.
This short film demonstrates how in the Bronze Age copper ore could have been smelted into copper metal using just a simple hole in the ground. Copper was the first metal used by humans. It is mostly found as a mineral ore. Turning the ore into metal is called smelting. Our experimental work has shown how this can be done in a simple hole in the ground, and also how it would leave very little archaeological evidence. For this experiment we'll be using a type of copper ore called malachite. This was extensively mined in the Bronze Age at the Great Orme Copper Mine, just a few miles down the road. First, a small pit is dug into the ground, here using an antler pick. small groove is cut into the edge to allow air from a set of leather bag bellows to be blown into the pit. The copper ore is then crushed on a small stone anvil. Many examples of these anvils are found at prehistoric mining sites. The ore is crushed into a fine powder. A fire is then lit in the pit. And charcoal added. The crushed ore is then sprinkled onto the hot coals. And more charcoal added. The end of the bag bellows is placed in the pit and a cap of turf placed over the top. Air is then forced into the pit by the bellows. This will increase the temperature inside the pit, creating a simple furnace. This is kept up for a couple of hours. Inside the pit, a reducing atmosphere is produced. The carbon monoxide, produced by the burning charcoal, bonds with the carbon in the ore, producing carbon dioxide and copper metal. This chemical reaction is what changes the ore into metal and not the temperature in the furnace. Changes in the colour of the flame coming out of the pit show how the smelt is progressing, and when it is complete, the cap is removed and the copper metal retrieved. The metal is a pinky yellow in colour. The remaining fill of the pit is washed to check for smaller fragments of copper metal using a simple panning technique. These fragments are collected together and put into a ceramic crucible and returned to the furnace to be melted together. After the smelt, you can see that the soils inside the pit have hardly been altered by the heat. Only the surface has been affected. The underside of the turf cap also showed a similar effect where it had been in contact with the heat. With the copper smelted, small amounts of tin or lead would have been added to produce the harder bronze alloy. This would have been poured into a mould, which when opened would reveal the bronze.
So green malachite and blue azurite were the major mineral copper ores used in producing copper. If these ores are strongly heated in an atmosphere starved of oxygen and rich in carbon, the metal is released from its ore, as shown, as you just saw in the YouTube video. The temperature of campfires is too low to extract copper from its ore, even though a campfire is a high carbon, low oxygen environment. Pottery kilns have been suggested as the most likely origin for the production of metals by the smelting of these natural ores, because pots were often decorated with pigments that were metallic glazes. And in the kiln, such as this one, these pigments could be converted to metals. Now, the earliest metalsmiths crushed the copper ore and mixed it with charcoal. Air was blown into the furnace to raise the temperature. The ore was rich in silica or quartz, and in the smelting, this silica melted to form a glassy slag containing copper grains. Later, metalsmiths learned that by adding iron ore to the furnace, the copper could be more readily recovered from within the iron silica slag. The metal globules could be extracted from the crushed slag and then remelted in clay crucibles to further extract the impurities. You can see here the type of kiln with bellows that was used for copper production around 1200 BC. Please also note the chemical reaction which occurs during the smelting of copper. So you can see here we've taken the copper ore malachite, and by the addition of carbon from the charcoal and oxygen from our bellows, we end up with copper and carbon dioxide being produced. About 800 years later, closed kilns were being used to smelt copper from its ores. The temperature in these kilns was so great that the copper melted and could be run out and cast into various shapes. The first cast copper artefacts were produced from stone moulds. Eventually, clay moulds were produced in a great variety of shapes, and from these, copper axe heads, spear points, daggers, arrowheads, and chisels, in addition to ornaments and utensils, could be cast. These copper tools were expensive to produce and not as strong as their stone equivalents. Despite this, though, copper became widely used, especially in the manufacture of eating utensils such as cups, plates, and forks. We now move on to the Bronze Age. Around 3000 BC, people in the mountainous area of Israel near the Dead Sea had found a means of producing harder materials from copper. Objects such as crowns and mace heads had been discovered. They are made from an alloy of copper and arsenic, which is harder than the pure copper. In ancient times, bronze was an alloy of copper and arsenic. The ores in which copper minerals are found are often contaminated with other metals such as arsenic, lead, nickel, and bismuth. Lead contaminants soften the copper, but arsenic contaminants produce a harder, finer product which is more readily worked and cast. Thus, arsenic bronzes became favoured over pure copper. By 3000 BC, it was discovered that tin produced the best alloy with copper. Tin bronzes, containing about 10% tin, are harder and less brittle than arsenic bronzes. Tin alloy could be more readily shaped and sharpened, and so cutting tools and weapons of war could be made from it. Kings and emperors demanded bronze for their palaces and tombs. Tin ores do not occur in the Middle East, and so they had to be obtained from Europe and Armenia. An extensive trade network developed with Europe by 2000 BC. And you can see the countries involved in the trade of bronze outlined in this browny orange colour. The European contact with the metalsmith of the Middle East led to the development of this technology in many European countries, including Spain around 1800 BC. By 800 BC, vast copper deposits were being mined